Solving linear systems of equations is one of the most important applications of matrices in mathematics. In this video, we'll talk about using matrix notation to solve linear systems of equations in MATLAB. Our objectives are first to learn how matrix multiplication is defined. This is as opposed to element by element that we've been using so far for matrices and vectors. We want to learn how to write a linear system of equations in matrix form. This may be review for some of you. This is sometimes covered in algebra classes. And we want to learn how to use MATLAB to solve a linear system. We are just going to scratch the surface of using matrices to solve linear systems. A lot of the mathematics here are content for linear algebra or Math 260, and you'll delve much deeper into the mathematics in that class. But we just want to get a brief introduction in this class because MATLAB is such a powerful tool for working with matrices. First of all, let's talk about matrix multiplication. Matrix multiplication is defined as follows. The elements in the matrix C that result from multiplying the matrices A and B are calculated using this summation. If you're not familiar with that notation, that sigma is a summation sign. And that notation will become more clear as we'll kind of go through this numerical example down here in the left-hand corner. So here we can see how the first element, in this case, let's call this matrix A and this matrix B, and we're going to multiply A times B and we'll get this matrix C. So the first element of C in the upper left corner will be equal to 3 times 5 plus, and that's the summation sign, so 3 times 5, A11 times B11, plus 1 times 7. So we're going to cross the rows in A as we go down the columns in B. So 3 times 5 plus 1 times 7 is 22. So the second element here would be 8 times 5 plus 6 times 7, or 40 plus 42. So this would be 82. And the third element would be 0 times 5 plus 4 times 7, or 28. So that's how we would calculate those first three elements. Moving to the second column, we use the 9 and the 2. So these two columns, these two elements to generate the second column. So for example, the first element in the second column of C would be 3 times 9, or 27, plus 1 times 2. So that's 29. The next one would be 8 times 9, which is 72, plus 6 times 2, which is 12, so that would be 84. And the third element would be 0 times 9, which is 0, plus 4 times 2, which is 8. Okay, so this is a definition of matrix multiplication, and there's some consequences here. One, you'll note the number of the number of columns in A, or n, must equal the number of rows in B. So these two must be equal. The number of columns in A must equal the number of rows in B. And then the outside dimensions, the number of rows in A and the number of columns in B, that gives us the those give us the overall dimensions or size of the result C. So let's look at how we do this in MATLAB. In MATLAB, this is the default operation. So if we define two matrices A and B, as we've done here on the left-hand side, then to find the product of A times B by matrix multiplication, all we do is write A times B, and you'll note The difference in what we've been doing now is there's no period. So if there's no period, then it produces a matrix multiplication instead of an element by element multiplication. So just to review, right, for element by element, A dot times B, that would be equal to, the result would be 2 times 3 is 6, 4 times 2 is 8, 6 times 1 is 6, 1 times 4 is 4, 3 times 3 is 9, 5 times 2 is 10, 1 times 5 is 5, 2 times 4 is 8, and 3 times 3 is 9. Okay, so that's element by element, and recall that these, in this case, A and B must be the same size. For matrix multiplication, we won't use the period, and if you recall from the previous slide, they do not need to be the same size, is not necessary, but the number of columns in A must equal the number of rows in B in order for this to be defined. So for example, we'll just take one of these, the 40. The way that's generated now, 40 would be 1 times 3. So we're going to go across the second row times the first column of B. So we'll go across the second row times the first column of B. So we get 1 times 3 plus 3 times 4 plus 5 times 5. So I'd recommend you kind of go through and make sure that you understand how this multiplication works and make sure that you can regenerate by hand. It is very important to understand what's going on here in order to be able to debug your MATLAB work. So you will want to practice by hand doing this matrix multiplication if this is something that's new to you. So once we've defined matrix multiplication, we can actually use this to write a linear system of equations in matrix form. This gives us a really concise notation for doing so. So if we have a vector x, so in this case we have a vector x that's defined as x1, x2, and x3, and this could be like 3 unknowns, for example, in a system of 3 equations and 3 unknowns. We can write this as a matrix A times x equals B, where A is a matrix of coefficients that we get by lining up the equations such that the coefficients of x1 are lined up, coefficients of x2 are lined up, coefficients of x3 are lined up, and all of the constants are brought to the right-hand side. So if we line up our system of 3 equations and 3 unknowns, many of you are probably already familiar with doing this in your calculator, we can line this up as 3 equations and 3 unknowns, and then use the definition of matrix multiplication to write this as a matrix multiplication with the matrix A times the column vector x is equal to the column vector B, or compactly, AX equals B. And then we can solve this using another operator in MATLAB that we haven't talked about yet. So there's 2 options for solving linear systems with MATLAB. One way is with what's called left division. Notice this is now a backward slash, not the forward slash that we use for regular division. So if we just write A backslash B, then we will solve for the unknowns x. The other option is to use matrix inversion. You'll learn more about matrix inversion in Math 260. The bottom line here is we can use the INV function, which is a built-in function for calculating the matrix inverse, But the matrix inverse is much less efficient computationally than left division, and it only works for square non-singular systems. We're not going to worry too much about the ramifications of that, only to point out that the preferred method is left division. We will worry more about why later on if you take Engineering 240 or applied numerical methods. We talk a lot more about why and the underlying mathematics behind a lot of what's going on with MATLAB. So let's look at an example of using MATLAB to solve a linear system. So here's a linear system given in the left-hand side. So we will define an unknown vector, a vector of unknowns x, which is just going to be the column vector x, y, z, and use that in solving this system. So the first thing we do is define our coefficient matrix A. Next we'll define B, which is our right-hand side vector. Note, again, with the rules of matrix multiplication, it's very important that B has to be a column vector. Note the elements are separated by semicolons to make that a column vector. And then we're just going to use left division to solve for x, and that gives us our final result. So x equals 7, y equals -8, and z equals 2. And that concludes this brief introduction to solving linear systems on MATLAB.